Hello, Algebra 2. Here we are with graphing parabolas, day 1. Alright, we got a nice jumbo graph up here. We're going to go over the basics of graphing y equals x squared. And we're going to start off with the t-chart. Okay, so we're going to be plugging in these points into x squared, getting our y coordinates, and we're going to come over here and plot them out. Nobody, not one class, made this mistake today, so let's see if you can do it too. -3 squared. +9. -3 times -3. Negative times a negative. +9. And what? +4. +1. 0. 1. 4. 9. Okay, now we're going to take these, we're going to put them over here. -3, (9). -2, 1, 2, 3, 4. -1, 1. 0, 0. 1, 1. 2, 4. And 3, 9. Okay, oops, went too far. There's 3, 9. Not there. Now, just like with our absolute value, now we're going to connect these, but it's not going to make a V like absolute value. Parabolas are going to curve and have like a U bend to them on the bottom. Okay? So when I connect these dots, it's going to have a U. It's going to be pretty steep early on here, and it's going to get in here and kind of gradually flatten out and make a U. And turn around and go the other way. Okay, so we're looking for a U this time instead of that V. Some things to notice. The bottom, beginning point, the corner, whatever we want to call it, is the vertex. Okay, the turnaround point is the vertex. With the absolute value, we might have referred to that more as the corner. It's not a corner anymore because it's rounded. It's the vertex, it's the turnaround point. Okay? Just like with absolute value, we can reflect these points over, fold those over onto each other. It has some symmetry, and we have a special line called the axis of symmetry that's going to go right down the middle. Now, this particular one is going to be tough to see because it is on the y-axis right now. But as we move these around, it will always be x equals the number of your x-coordinate from the vertex. The x-coordinate from the vertex. Okay, our y-intercept this time is 0, 0. That's where we cross the y-axis. And that will always be 0, the y number. Okay? Always will begin with a 0. And then a points pattern. Okay, there's a pattern here with our points. Perhaps in Algebra 1 or whenever you first graph these the first time, you probably had to make a T-chart like this every time. Okay? I'm here to share some patterns with you that will help go a lot faster. Okay, now you might just see these because it's 0, 0 for the start point, but this works no matter where it is. Once you find your vertex or your starting point, you can use this pattern. Okay, over 1 from your vertex, you would then square 1 and go up 1. Over 2 spots from your vertex, wherever it is, over 2 spots, square it. Now you got 2 squared is up 4. And if you go out 3 spots from your vertex, 3 squared is up 9. Okay, so this pattern happens everywhere, no matter where this is. This could be at -1,000, 25, and it's still going to be over 1 up 1, over 2 up 4, over 3 up 9. Okay, when we do some of these example problems, we'll talk about a multiplier and how those will change it. But for the most part, that's the same pattern every time. When we were working with absolute value, and we talked about this pattern in this format for the formula. We said it's going to happen. We're going to use the same setup for every function the rest of the year. Absolute value to x squared, to later on x to the third. Then we'll have square roots, sine, cosine. Okay, it's all going to follow this. The number inside with x is going to go left and right, opposite of what you think. Plus goes left, minus goes right. Outside number goes up and down, normal, plus goes up, minus goes down. Multiplier in the front is going to stretch it out or shrink it down if it's a small fraction. And if it's negative, it's going to flip it upside down. All right, let's turn the page and get started. All right, a minus 2 on the inside is going to go right 2. So instead of 0, 0, we're going 1, 2. We are going to be at 2, 0. I like to write down the coordinates of the vertex because you're going to use those two numbers again, 2 and 0. So it's really nice to have them right in front of you. Okay, now whether you do your axis of symmetry next, or you do some dots next, and then the axis of symmetry, I don't care. But if we go over one unit, one box, from our vertex, 1 squared is 1. Go up 1. If I go out 1, 2 units, 2 squared is 4. 1, 2, 3, 4. Okay, now that would be the minimum requirement for a quiz or a test. It's our beginning, it's our very first time, and there's room for it, so let's go out 3. 1, 2, 3. 3 squared is 9. Go up 9. Next, we need our axis of symmetry. It's a vertical line that goes right through the middle of the vertex. And because it's a vertical line, it's going to be x equals. And because it's x equals and goes right through the vertex, you should know it's going to be the same as the x number of your vertex, x equals 2. Then we can reflect these dots over the line. So this dot is 1 away from the line. Go 1 past the line on the other side. 1, 2, 1, 2. 1, 2, 3, 1, 2, 3. And there are the reflections over the line. Smooth it out, smooth curve. And we are done with the graph part. Now we have to answer or provide some information. Okay, our vertex is 2, 0. You can write vertex or just abbreviate it V. Axis of symmetry. I go A period S. Some teachers go A dot O dot S. Axis of symmetry, x equals 2. Your y-intercept. Most of these will be very friendly. Some of them Mr. Handke messed up on, and they won't have a very nice y-intercept. But they will be nice on the test. Y-intercept we cross at 0, 4. And guess what else makes a return for parabolas? Your best friends, domain and range. I know those aren't our favorite things, but these should be pretty easy. Because just like absolute value, domain is all real numbers, and range is going to be directly related to your y-coordinate from your vertex. We got y with a 0, and our parabola is going up, so it's greater than or equal to 0. All right, you push pause and try this one over here. Ready, set, go. Okay, let's check it out. Minus 2 on the outside is going to be up and down. So we're going to be at 0, negative 2. Okay, so we go over 1, up 1. Over 2, up 4. That'd be the minimum. I did over 3, up 9 as well. Then we have our axis of symmetry, which happens to be the y-axis. X equals 0, matches the x-coordinate. Flip them over. curve it out, and let's answer our questions. Our vertex is 0, negative 2. Our axis of symmetry is x equals 0. Our y-intercept is also 0, negative 2. That happens once in a while, that your y-intercept and vertex are the same point. Domain is always all real numbers, and your range, y's, are greater than or equal to negative 2. Again, that y number from your vertex, negative 2, should match with your range, and then you just need to think about going up or down. Let's do one with 2 shifts. Okay, we're going to be left 2 and down 3. Negative 2, negative 3 for your vertex. No multipliers yet, so it's just over 1, up 1, over 2, up 4. Let's get that axis of symmetry right down the line through the vertex, which reminds me it should match the vertex x number, negative 2. Flip these points over. And curve it out. Okay, again, our vertex is negative 2, negative 3. Axis of symmetry this time is negative 2. Our y-intercept, 0, 1. We cross the y-axis at 1, 0, 1. Domain is always all real numbers, going with the fancy R. And our range should match this y-coordinate of the vertex. Y, negative 3. We're going up, so it's greater than or equal to negative 3. Okay, you got the next one. It does have a negative multiplier in front, so be careful. Think about what that would do. Negative flips it upside down. So instead of our points pattern going up, our points pattern's going down. Go ahead and push pause and see if you can get this one on your own. Alright, so we should be 1 to the right and 2 up. And our negative is going to make it go over 1, down 1, over 2, down 4. Put that axis of symmetry down the middle, x equals 1. Flip your points over. Curve it out. Okay, again, your vertex is 1, 2. Axis of symmetry should match the x-coordinate of your vertex, x equals 1. Y-intercept just happened to be 0, 1 again. Domain is always all real numbers. And our range should match the y-coordinate of a vertex, something, something with a 2. We're going down this time, so y's are less than or equal to 2. Okay, I'm going to talk through this next one with you, and then you'll have the last one on your own. We're going to go bottom right together, because it has a fraction, and there are some choices to be made when it comes to fractions. Okay, so we're 5 to the right, 1 up. 5, 1. Again, I like to write that vertex down there because we're going to use those two numbers again later. Now, we have a fraction times a half. So you're going to multiply all your points pattern times a half. So normally we'd go over 1, up 1, but it's times a half, so you're only going to go up a half. Now, that up a half, you know it's a half. I know it's a half right now. But if it was on a quiz or a test and you did it and then you turn it in and then I go to check it later, I'm not a mind reader. I don't know it's a 0.5. So you would have to label this as 6, 1.5. Somewhere in the ballpark of that area. If you don't like that, you don't want to label those points, you're going to need to find some perfect points, some nice points. So if I go over 2, 2 squared is 4, but it's times a half, so cut it in half. Over 2 up 4 becomes over 2 up 1, 2. Those are nice perfect points, so I can let it go without labeling. If you don't mind labeling it, you've got your 2 points and you're ready to flip them over and graph away. If you don't like writing those labels on there, you're going to have to use your brain a little bit and try to come up with another nice one. Over 3, 3 squared is 9, cut that in half, that's going to be 4.5. That's not going to be very nice. So you're going to have to go out 4. 1, 2, 3, 4. 4 squared is 16. Cut that in half, that's up 8. Okay? Then when we flip those over, we'd have really nice points, and we can graph it out. Okay? So if you get a fraction one, you got some choices to make. Do you want to go through and try to get perfect points that you don't have to label, or do you not care and you just go over boom, 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 and have to label probably 1 point and move on? Okay? Sometimes the hard reality is sometimes you're not going to be able to find 2 perfect points, and you're going to have to label one before reflecting it over. Okay? Let's have you try the last one over there. It's got a times 2 in the front. When you have whole number multipliers, it's pretty easy because you're taking your pattern times 2. So up 1 times 2 becomes up 2. Up 4 times 2 becomes up 8. There's no problems. Okay, with fractions, sometimes you have problems because they don't get nice points. So go ahead and push pause and try that one. All right, welcome back. We should be 3 to the left and 4 down. 2 times multiplier, so over 1 is now up 2, twice as much. Over 2 is usually up 4. Now it's up 8, twice as much. We got our line of reflection, axis of symmetry. Flip them over. Our vertex is -3, -4. Axis of symmetry should match the x number there. X equals -3. Y-intercept, again, these bottom 2 problems I didn't do a very good job of. 0, 14 is coming from, it's always 0, so we're going to throw a 0 in there. 0 plus 3 is 3. 3 squared is 9. Times 2 is 18. Minus 4 is 14. So that's where that's coming from. On an assessment, it should be nice when it cuts right through. Domain is always all real numbers. And our range should match our y coordinate, -4. And we're going up, greater than or equal to -4. All right, thanks for watching, kids. Good luck on your homework. Let me know if you have any questions, and we'll see you next time.